Oh no. So guys, can you imagine the angle of Ali's arm when he is holding Silky? And what the force that Ali required to hold Silky hand? So let us calculate together.
Alright, so right now our group will present the solution for case 1. So the question is identify, solve, and calculate the parameters to determine the angles of Ali's arm when he is holding Seo Gi-hun. Okay, so this is our assumption to solve the questions. First, the distance between both Ali's leg is equal to the distance between Ali's left leg and Seogi's hip. Second, both distance at number 1 is 3 times of the distance between Seogi's left leg and Ali's right leg. So this is our illustration. So the data that we collect to solve this question is: first, height of Seogi is 1.81 meter. Second, weight of Seogi is 71 kilogram. Third, height of Ali is 1.73 meter, and the last one is weight of Ali is 65 kilogram. So this is our illustration that we illustrate to solve the question. And, and this is the formula that we use to solve the questions. For solving this problem in case 1, first we need to find theta 1. And inverse sine 1 over 1.81 will get theta 1 equal to 33.454 degree. And we need to find the value of AC, but AC equal to 7x, right? So by using the hypotenuse rule, we can find the value of x equal to 0.216 meter. And right now we can find the value of theta 2 by inverse tan 1 over 6x. We substitute the value of x into 6x, and we will get theta 2 equal to 37. So next, we need to find the value of dB, and using the hypotenuse rule, we can get the value of dB is 0.815 meters. And for information, based on the illustration, the total of degree for triangle is 180. So right now we can find theta 3 by 180 degree minus 90 degree minus 33.54 degree. We get theta 3 equal to 56.46 degree. And based on the illustration, we can conclude that theta 3 equals to theta 4 by zigzag rules. Okay, so right now we find the value of DE by using cosine rule, and we will get DE equals to 1.68 meter. And by having the value of DE, right now we can find the value of theta 5. By using sine rule, we can get the theta 5 is 25.75 degree. Okay, just an additional information based on the research entitled A Human Body Mathematical Model Biometry Using Golden Ratio, a new algorithm written by Ibn Abu Tai and Hamid. They are based on the research. Leonardo da Vinci developed 15 proportion rules used to model a human in his work named Vitruvian Man. The famous proportions were written underneath the illustration shown in the figure. So based on the figure, we can conclude that Ali's arm ratio is 3 over. So right now, it's easy to find the value of DF, which is Ali's arm. 3 over 8 times 1.73 meter, which is Ali's width, is equal to 0.649 meter. And right now, we can find theta 6 by 90 degree minus theta 3 plus theta 5. And the value of theta 6 is 59.29. So to finalize our solution, we need to find FB. FB, we are using the cosine rule, and we will get the FB is equal to 0.738 meters. And by having the value of FB, we can find theta 7, which is the angle of Ali's arm, which is holding Seogi. And by using sine rule, we can find theta 7 equal to 71.71 degree. And to conclude that the angle of Ali's arm when he's holding Seogi is 71.71 degree. That's all from case 1. Thank you.
So for case 2, it said that identify, solve, and calculate the parameter to determine the force that Ali required to hold Seo Ji-hoon. So this is the two assumptions that we have made, which is the first is 10% of the force of Seogi body which tend to fall into land F2 is supported by Earth. Second, force of Seogi's body which tend to fall into land F2 is the same with the force that Ali required to hold Seogi Hun, which F1 if theta A if theta A is equal to theta B. So this is the data and information that we get from internet. So first is weight of Seo Gi-hun is 71 kg. Second, gravity of Earth, which is G, is equal to 9.81 ms negative 2. And the third is force is equal to weight, where weight is equal to mass times by gravity. So this is all of the data that we use for this case 2. This is the illustration that we get from the Ali and Seo Gi-hun. So for the first, we find the force, which is the weight for Seo Gi-hun, which W is a downward force. So 71 is times is multiplied by 9.81, which is gravity. So the weight of Seo Gi-hun, which is the force downward, is 696.51 Newton. So based on case 1 that we have searched for all of the angle of the illustration, so we can find theta A here. This is the solution.
Okay, so we can find theta B by 90 degree minus theta 3, which is 90 of theta 3 we can get from case 1. So 90 degree minus 56.46 degree, and we get the theta B is equal to 33.54 degree. And based on the illustration, we get that force 2 equal to W sine theta B, and we substitute the values, and we get the F2 equals 383.
So this ratio is made from the assumption that we have made earlier, which is the angle if force 2 is equal to the angle if the angle is same. So we have made a ratio here, which F2 divided by theta B is equal to F1 divided by theta A. So based on the value that we get earlier, we substitute into the formula, and we can see that in the formula have 90 over 100. That is mean by the first assumption, the second assumption that the first assumption that we made, which 10% of the force is supported by the Earth. So we substitute into the formula, and we get F1 is equal to 271.32 Newton, which are the force that Ali required to hold Seo Gi-hun.
Got it. So I want to continue watching this. That's all from us. Thank you.